welcome to our channel JET. So today we are going to discuss about the important questions which are going to occur in your tomorrow's exam. So right now we'll be focusing on the theory questions, and later let's see about the numerical questions. So this video will be only on the theoretical questions. So let's get started. So module 1. So the first question, define simple harmonic motion and mention its characteristics. Give example. So from the first question, you have to first define it. Then you have to talk about the characteristics. To the total 5 points based on the marks, you can write accordingly. And then you have to give an example, minimum 2 examples, right? So now moving on to the second question, we have derived the differential equation of SHM using Hooke's law. So for that, the answer format will be, first you have to derive, this is what you have to derive, guys. D square x by dt plus omega square x is equal to 0 using f is equal to minus k of x, right? Next, third question, what are damped oscillations? Derive the general solution for damped oscillations and discuss the case of critical damping. So as usual, you have to define it, then derive. B square is equal to omega square, right? For critical damping, it will be B square equal to omega square. So the format is most important. This is the format you're going to write in the exams, so that you get the complete set of marks. So now moving on to the fourth question, what are forced oscillations? Derive the expression for amplitude and phase angle in forced vibration. So the answer format will be, first you have to define, then you have to derive. This is for the amplitude and this is for the phase angle. This is exactly what you're going to derive. Don't get confused, right? For this question, you're going to derive these two elements, right? Now, obtain the expression for amplitude resonance in forced oscillation. So this is nothing but the same question as above. So this is what you have to derive. A is equal to F by M divided by root over 4B square P square minus brackets omega square minus P square whole square. Yes, guys. Okay. So now moving on to the sixth question. This 6, 7, 8 will be on shock waves. So sixth question, what are shock waves? Mention their characteristics and applications. First, you're going to define it. Then characteristics, there are 7 points. Out of that, based on the marks, you guys know how much to write. So just take care. Then rest you can leave it for applications. Now, question number 7. Describe the construction and working of reddish shock tube with a neat diagram. So for this question, you have to draw the diagram, definitely. Then explain the construction, then write the working. So explanation of the construction will be around 2 to 3 marks. Drawing will carry 1 mark. Working will be about 5 to 6 marks. What is match number? Classify shock waves based on match number and give examples. So definition and classification will be acoustic, subsonic, supersonic, and ultrasonic, and you have to give examples for each. Next, coming to springs and oscillations. Define force constant. Derive the equivalent force constant for spring connected in series and parallel. So the answer format will be first definition, then you have to draw the diagram for separately for series and separately for parallel, right? And you have to derive it individually. So this is for parallel and this is for series. Don't get confused. Practice properly and go to the exam so that you know which one comes for which one, right? So once again, I'm repeating, 1 by Ks equal to 1 by K1 plus 1 by K2. This derivation will be for your series connections of spring. And for parallel, it will be Kp is equal to K1 plus K2, right? Okay, moving on to the next question. Derive the expression for the period of oscillation for a spring mass system. So as usual, diagram, right? Then you're going to derive it. T is equal to 2 pi root over M by K. This is what you're going to derive. Next, moving on to module 2. So in module 2, you have particle in a box. So Schrodinger's equation, obtain the eigenfunction and eigenvalue for the particle in one-dimensional potential well of an infinite height. So you guys know this. what to derive. So no confusions, right? Then this is again the same question, guys. Okay, and you will be having obtain the normalized waveform. That will be another one more line, guys. You guys know it. Yeah. Now moving on to wave functions and Schrodinger's equation. What is a wave function? Arrive at the time independent Schrodinger wave equation. So this is what you are going to derive for this question and the below question. They can ask in another form saying that set up the one-dimensional time independent Schrodinger wave equation. Don't get confused. Both are the same question. Now moving on to Heisenberg's uncertainty principle. So the first question, state and explain Heisenberg's uncertainty principle. You use it to show the electrons cannot exist inside the nucleus. I think this is the most important question. You can see how many years it has been repeated. So the first point, you're going to state Heisenberg's uncertainty principle. The second one, you're going to explain it, right? Or what does Heisenberg uncertainty principle talks about? Then you're going to derive it. Okay. Yeah, there's only one derivation. There's no confusion. So I didn't mention what to derive, right? Now coming to black body spectrum. Deduce Wein's displacement law and Rayleigh-Jean's law from Planck's radiation law. So this is what you're going to derive for Wein's displacement law from Planck's radiation law. And this is what you're going to derive for Rayleigh-Jean's law from Planck's radiation law, right? Okay, deduce, it means you have to derive. Okay, no confusion, right? Instead of this question, some other question, if they mention deduce, it means you are going to derive it. Okay, yes. Now moving on to the next question. Discuss the spectral distribution of energy in black body radiation and explain Wein's displacement law. So in this question, you will have, this is what you are going to draw and explain. Lambda m is proportional to 1 by t, right? And the same question can be again asked in a different way, saying that show how Planck's theory explains the complete black body spectrum, right? This is the same question, guys. Okay, now moving on to module 3. Optical fibers. What is numerical aperture? Derive its expression from an optical fiber. So you're going to draw this diagram in a neat and clean way. Mention all the elements here. Okay, core, incident ray, cladding, everything have to mention. The diagram has to be as it is. Then you get the marks. So drawing will be probably 1 mark, definition 1 mark, and rest goes for your derivation. What is your derivation? Na is equal to root over n1 square minus n2 square. This will be around 6 to 8 marks. Next question. Define fractional index change. Derive expression for numerical aperture and acceptance angle. Numerical aperture derivation is in the above, and acceptance angle will be your sine theta I is less than Na. Okay, and define fractional index change. You have to define it. Okay, so that is nothing but delta is equal to n1 minus n2 divided by n1. Explain total internal reflection, acceptance angle, and numerical aperture. Derive the condition for propagation. So we're going to define it. Then individually you're going to write down the formula for each one: internal reflection, acceptance angle, numerical aperture. Then you're going to derive it, right? Okay. So derivation will be for the condition for propagation. All right. Okay. Now moving on to the next question. Classify optical fibers based on refractive index profile and modes of propagation. So classification, it will be single mode, step index multimode, graded index multimode, right? And they have asked for refractive index profile. So you are going to draw this diagram individually for each one, right? Yes. Now moving on to the next question. Explain different types of optical fibers with neat diagram and mention the mechanism of fiber losses. So classify, okay, then absorption, these are the losses: absorption, scattering, and radiation losses, right? That is for your second part of the question. Okay, the first part is again covered from this question, both the same, right? Define V number, calculate the number of modes supported by the fiber. Okay, so definition will be carrying 1 to 2 marks, and this is what you are going to derive. Okay, this is what you are going to use for calculation. Okay, V is equal to pi d by lambda root over n1 square minus n2 square. So this will be in the numerator part, not a denominator part, right? No more confusions. Now coming to laser part, explain induced absorption, spontaneous emission, and simulated emission with rate equation. So first you're going to explain, draw individually the diagrams. Okay, then equation rate. Equation rate is nothing but all these equations are there. You guys might get confused, so I have mentioned all these. So you have to mention individually for each one. All right. Yes, moving to the next question. Derive the expression for energy density using Einstein's coefficient. Okay, this is what you're going to derive. Okay, going to the next question. Define population inversion and metastable state. Right? So definition of population inversion will be for 2 marks and metastable state will be for 2 marks. Totally, you might get it for 4 marks. Okay, so you have to segregate it in this way, right? Next, describe the construction and working of CO2 laser with energy level diagram. So drawing, then explain the construction and working. Okay. Next, describe the construction and working of semiconductor laser. So mandatory, you have to draw again, even though if they don't mention construct the diagram or draw, you have to draw, right? Then again, you have to write the working. Yes. Okay. Now explain application of lasers in defense and medical applications of eye surgery and skin treatments. This is not a proper question, but we have given you so that it may not be a complete question. It might be in a splitted form. So you have to learn all this, right? This is not a question. We have given you to learn, right? Individually they might ask. Okay, guys. Yeah. Now moving on to the next question. Point-to-point communication. Here we have explain the basics of point-to-point communication using optical fiber. Or they might again ask it as from the 9th question. Describe a block diagram for fiber optic communication system. So both the same question. Don't get confused. So this is the block diagram mandatory you're going to draw. And from the block diagram itself, you can explain. So that is what all about block diagram is. So it is very easy. So you can have a glance about the how it works through the theory part, but in case if you get confused in the exam, from the block diagram you can write. Okay, those are the skills you should know to crack the exam. Now moving to module 4, quantum free electron theory. Now state the assumptions for quantum free electron theory, explain its merits over classical theory. Okay, assumptions and merits. 4 points for assumption and merit 6 points. Based on the marks, you can write accordingly, right? Energy variation, this is as a set of question and the above one. Derive the expression for Fermi energy level at absolute zero temperature. So out of the 3 points, which is E is less than E of F, E is greater than E of F, and E is equal to E of F, the 3 cases, out of the 3 cases, you're going to only write and explain E is less than E of F and E is greater than E of F, because that is only condition where T is equal to 0, right? Yes. Moving on to semiconductor physics. Okay. Now describe Fermi level in intrinsic semiconductors and derive expression for Fermi energy in terms of energy gap. Now first you're going to explain it, which will be around 4 to 5 marks. Okay, then derive. What you're going to derive? E of F is equal to E of G by 2. This is what you're going to derive. Next, what are charge carriers in semiconductors? Derive expression for electrical conductivity in semiconductors. So first definition 1 mark and derivation. This is what you're going to derive, guys. Okay. Next, we are coming to dielectrics and polarization. What is polarization? Explain electronic, ionic, orientational, and space charge polarization mechanism. Okay, as usual, polarization definition will carry 1 mark, and rest of them you have to explain with the diagram. Most important. The next question: derive Clausius-Mossotti equation for polar dielectrics. Right. So this is your derivation. Okay, guys. Okay, moving on to the next question. Define internal field in dielectrics. Derive expression for Lorentz field. Okay, you are going to define and derive. This is what you're going to derive. Okay, E Lorentz, which is equal to E plus P 3 epsilon naught, right? Okay, yeah. Now moving on to the next question. Differentiate between polar and non-polar dielectrics with example. So any kind of differentiation, it's better to go with a partition method, which is you're going to divide the sheet into two halves. Left hand side you're going to write polar, right hand side non-polar. If you write in that way, you're going to score good marks, right? That is how the evaluators expect from you guys. Next, Hall effect and conductivity. What is Hall effect? Derive expression for Hall coefficient and Hall voltage, right? This is for your Hall coefficient. RH is equal to 1 by NE. This is for Hall coefficient. For Hall voltage, V of H is equal to VH is equal to RHBI by omega. Derive expression for electrical conductivity in metal using free electron theory. Okay, so this is what you're going to derive. Okay, so sigma is equal to Ne square lambda divided by M into Vf. Explain the dependence of conductivity on temperature for metals and semiconductors. So simple, can explain, right? Now, from classical free electron theory topic, you might get two questions, right? One is assumptions, another is failure, right? So assumptions, you have 4 points. Failure due to specific heat and due to temperature and due to electrical conductivity. Module 5, nanomaterials and characterization. What are nanomaterials? Classify them based on dimensions with example. So the answer format will be first definition, which is for 1 mark, and the classification will be on 3D bulk materials, 2D film, one-dimensional quantum wire, and zero-dimension dot. Okay, this is going to be for around 4 marks. You have to draw diagrams also, mandatory. So this is the diagram you're going to draw, right? And you're going to explain that, right? Yes, moving on to the next question. Explain principle, construction, and working of scanning electron microscope. Okay, SEM, they may ask in short form SEM. Okay, so principle 1 mark, construction 1 mark, and you are going to explain it for 2 marks and working the rest of the marks, right? Next, transmission electron microscope, which they may mention is that TEM, atomic force microscope, AFM. Okay, so all these three, you'll have this kind of splitting of marks. So this is like a marking scheme. Okay. Describe construction and working principle of X-ray diffractionometer, right? So for this question, you're going to describe the construction and working. Okay. Next question, explain Bragg's law of X-ray diffraction. Derive the Bragg's equation, right? So Bragg's equation derivation will be 2d sine theta equal to n pi, and the explanation will go with the 3 points. The first one, you have to explain X-ray source. The second point, you have to explain about the crystal fixed on a circular table provided with a scale and vernier. Third point, ionization. We are going to explain all these three, right? And derivation will be for the Bragg's equation. Okay. So the next question, question number 5. Describe principle and working of X-ray photoelectron spectroscopy, right? So for this question, 1 mark for your principle, then 1 mark for your diagram, and rest goes for your working, right? Okay. What is Schreier equation? Derive expression for crystalline size determination. Okay. Okay, so the first 1 mark will go for your definition, and second will go for your derivation of the shear equation, right? Okay, now coming to the next question. Okay, this is on advanced materials. Explain what it is and properties and application of. Okay, you might get a question on nano composites. Okay, so 1 mark for what is it, which is your definition. Properties, you'll be having 3 points for your properties, and based on marks you can write accordingly. And application, it's better to specify 3 to 4 applications, right? Yes. Now coming to the next question, what are shape memory alloys? Explain their working principle and applications. So definition 1 mark, and rest goes for your working, and application again you can hold with 3 to 4 points. Okay, so that's all guys. So I hope you like the video. Prepare well for your exams. All the best guys. So let's meet up in the next video. Thank you.